Welcome to Akbar Academy. Today we are tackling a question involving thermal physics, specifically focusing on heating a room with an electric heater. This question will help us apply principles of density, specific heat capacity, and energy transfer. Let's break this down step by step. Part A1. Finding the mass of air in the room. The question provides the dimensions of the room: 4.5 meters by 6.1 meters by 2.4 meters. The density of air is given as 1.2 kilograms per cubic meter. We are tasked with showing that the mass of air in the room is 79 kilograms. Step 1. Calculate the volume of the room. Volume equals length times width times height. Substituting the values, volume equals 4.5 times 6.1 times 2.4 equals 65.88 cubic meters. Step 2, use the formula for mass and density. The formula connecting mass, density, and volume is mass equals density times volume. Substituting the values, mass equals 1.2 times 65.88 equals 79.056 kilograms. Rounding to match the solution, mass equals 79 kilograms. Part A2, calculating the time required to heat the room. We are given power of the heater equals 1100 watts. Specific heat capacity of air equals 1000 joules per kilogram per degree Celsius. Initial temperature equals 16.0 degrees Celsius. Final temperature equals 20.0 degrees Celsius. We need to calculate the time required to increase the temperature. Step 1. Calculate the energy required to heat the air. Use the formula energy equals mass times specific heat capacity times temperature change. Temperature change equals final temperature minus initial temperature equals 20.0 minus 16.0 equals 4.0 degrees Celsius. Substituting values, energy equals 79.056 times 1000 times 4.0 equals 316,224 joules. Step 2. Relate energy and power to find time. Power is the rate of energy transfer. The formula is power equals energy divided by time. Rearranging for time, time equals energy divided by power. Substituting values, the time equals 316,224 divided by 1010 equals 287.4764 seconds. Rounding to match the solution, time equals 290 seconds. Final answer, the time taken is 290 seconds. Part A3, explaining why this is the minimum time to heat the room. The time calculated in part A2 is the minimum time because not all the thermal energy from the heater goes into raising the temperature of the air in the room. Some energy is transferred to furniture, walls, or objects in the room, the surroundings such as windows, doors, or the ceiling, through thermal energy losses. Part B, methods of thermal energy transfer reduced by the window. The diagram shows a cross-section of a double-glazed window with a narrow air gap between two glass panes. Double glazing reduces heat loss from the room to the outside environment by conduction. The air gap acts as an insulating layer, slowing down the transfer of heat from the warmer room to the cooler outside because air is a poor conductor of heat. Convection. The narrow air gap prevents air movement between the panes, reducing heat transfer by limiting circulation, which would otherwise carry heat from the room to the outside. This is because the particles in air are spread apart, making it harder for heat energy to pass through. Final answer. The main methods of thermal energy transfer reduced are conduction and convection. Thank you for joining us at Akbar Academy. Keep practicing and see you in the next lesson.